Well, we're back in our third of our series of lectures going over how the unit circle representation is one way we can represent trig functions, but another way is with a Cartesian graph. So we started with seeing how sine could be seen as the y value here on the unit circle. It's also the y value in the Cartesian graph. The input is the angle over here in the circle, same as this arc length, which is the x value here, and that gives us a graph of sine. Similarly, cosine, the input again is the x value here, which is this pink arc length, which is the same as this x value here. So over here, it's in the unit circle, it's an angle. In the Cartesian graph, it is a x value. The x value over here, this point P, is the y value on the cosine graph, the blue graph, and the y value over here on this one is the y value on the sine graph. Okay, and so we can see how that point moves around. It's the same x value, but different y values over on the right, which correspond to the x value for cosine and y value for sine of the point P over here. Now we want to find what happens with tangent. Now we can look at this a couple of ways. We can actually divide the y value by the x value, which is the definition, but there's also another way we can see tangent. And one way we can see tangent on the unit circle is to take our unit circle and draw the tangent line to the circle at the point 1, 0. Then we take the line through point P, and we see this point right here where it crosses this line, and that is going to be the tangent. Why is that true? Well, look at this right triangle right here where we have a right angle at this point 1, 0, and notice that it is the tangent of the angle then is basically opposite over adjacent. Well, opposite is this length here, right here, to this point from here. And that is, let me make it where you can see a little bit better. So this green length is the opposite, and the adjacent is this length right here, which is just 1, right? Because this is a unit circle. So green length over 1 is the tangent of that angle, so the green length is the tangent. Notice that it works out just fine if you're in this quadrant. Okay. When you're over here in this quadrant, you need to take the line going down here so that we get a negative length here. Same reference angle, okay, as we have over here. So it's going to be the same size as opposite over adjacent in this little triangle down here in the fourth quadrant, even though the terminal side is in the second quadrant. Same angle, reference angle, right here as there is here. So the tangent is going to have the same size, but notice it should be negative in here. And when we're down here in the third quadrant, we're back here in the first quadrant on the drawing of the green line, and this quadrant down here will be negative. So that, if you always just take not the ray, but the line containing that point, and see where it intersects this vertical tangent line, you get the value of the tangent function. Now let's look at the unit circle. We'll get to the other graph in just a minute. If we look at the unit circle, look what happens. Tangent's going to start out at 0, and it's going to get bigger and bigger and bigger. When you get halfway in between 0 and a right angle, in other words at pi over 4 radians, 45 degrees, you're going to get a tangent of 1. So we're right, not quite there, let's see. Yeah, that's really close right there to 1. Now, as we go around here, it's going to get bigger and bigger. What happens as it gets closer and closer to here? Well, actually, it's getting bigger and bigger and bigger, going towards infinity. When you actually get right here, vertical, okay, I don't know if I get it perfectly vertical, but if you get it exactly pi over 2, then actually this line, the ray here is actually, the line containing this point and this origin is actually parallel to this tangent line, and so there is no green length to actually look at, and in fact tangent is undefined. But if we go a little bit to the other side, tangent is negative, but it's way down here, close to negative infinity, and coming up from negative infinity, up closer and closer and closer to, when you get actually halfway in here, we're at negative 1, and then, excuse me, and as we go around here, we work our way back up to 0. So again, let's go here. First quadrant works its way from 0 up to, well, towards infinity. Then the next quadrant starts close to negative infinity, comes back up, working its way from negative infinity up to 0, and then this keeps going, working its way up to positive infinity, and then it works its way back down here. So let's watch what happens over here on the graph on the right. So if I take any point here, notice I'm taking this, again, all of these, the input is the angle on the left, which is the same as this pink arc length right here, but the input on the right is this x value here, which is a horizontal length. So those two pink distances are the same, but the two green distances are the same here, and you can see that coming across by this horizontal line right here. And that green distance is the tangent of that angle. The angle is on the left, it's the tangent of the x value on the right graph. Okay, and so we can see that tracing its way. Now watch the point on the right side. It starts at 0, shoots off towards infinity, then it's going to come in at the bottom of the graph, coming up from minus infinity up to finally hitting at 0 at pi, and then going on up towards infinity at 3 pi over 2, and then back up. So it's going to trace it like that. Now let's actually see what that traces out. That traces out a graph like this. So it starts at 0, goes up, concave up there, pi over 2, it's undefined. Then we can go down here and come back up, hitting 0 and coming up, and it repeats the whole pattern once again. So that pattern, just like the sine and cosine, those patterns are repeated again. A little bit different shape of graph than the sine and cosine. Sine and cosine were pretty similar, but the tangent is quite a bit different. For one thing, it's got some undefined points, and so if we graph the tangent graph, it goes like this, and it just keeps going. The same pattern, let's get a little bit more of it graphed. The same pattern just keeps going over and over and over again. And notice actually the tangent pattern actually starts repeating every pi. We noticed this before, that the period of the tangent is pi. And so if we go back here, let me get this back kind of where we had it over here. And so notice that, for example, if we want a connected piece, we could go from maybe minus pi over 2 to pi over 2. Those two vertical asymptotes at those two vertical lines right there. And in between we have one full period. And that is repeating over and over again. Whereas for sine or for cosine, to get a full period, we had to go, say, from 0 to 2 pi, or any length that goes from any length here that goes from a length of 2 pi. Okay, so there you can see sine, cosine, and tangent all graphed together. So notice when sine is 0, like right there at pi, 2 pi, multiples of 2 pi, 0 multiples of pi, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, then tangent is also 0. When cosine is 0, sine is 1 or negative 1, and tangent is undefined. We have our vertical asymptotes there. So this little box right here goes from 0 to 2 pi, and within that you're going to see one full period of sine and cosine, and at least it goes out of it vertically, but horizontally you're going to see one period. You can see two periods, excuse me, of sine, actually. Okay, so let's review real fast. Okay, if you have sine, if you have any of these, sine, cosine, or tangent, okay, the x value here is the angle over here in the other picture. So what you see in pink here is the pink here. It is the x value on the right. It is the angle on the left. It's not really an angle over here on the right. It's an x value, but it's an angle over here in the unit circle picture. What's y over here is the y over here for sine. And so you get a graph like that as this point traces around. What's x over here on the left is the cosine on the right, and it traces around that. The tangent on the left is found by taking this tangent line to the unit circle at the point 1, 0, finding where the line through the origin and this point on our terminal side goes through this, and the y value there is the value of your tangent. And so as you rotate around, you can see the same x there tracing out the sine, the cosine, and the tangent. If you look at them back a little ways here, you can see more of the graph, and so you see what we see here. And especially you're going to see what you especially see is the periodic nature of these functions. Okay? And so you can see the sine, cosine, and the tangent all there. Okay, so there are graphs of all three of the basic trig functions. In the next video, we'll look at how we can find cosecant, secant, and cotangent.